Hello everyone, myself Payal and I am here to discuss about Naïve Bayes classification. So, Naïve Bayes is a simplified classification algorithm that uses probability to predict the category of a given data point. It works by calculating the likelihood that a data point belongs to each possible category, assuming that each feature in the data contributes independently to the outcome. The algorithm then picks the category with the highest probability. This method is especially popular for tasks like email spam detection where it quickly determines whether an email is spam or not spam based on the words in the email. Now, we will demonstrate application of Naïve Bayes using Python. It is a simplified explanation with all these steps in it. So, first step will be in first step, we will import the required libraries. First, we will import the pandas. So, pandas we will import for data handling. Then we will import NumPy for numerical operations, and then we will import multinomial and be from sklearn for Naïve Bayes classifier. Then we will import stats models for converting categorical data into dummy variables. The next step will be loading of the data. So we will load our training and testing data. These will be called WINE-TR for training data and WINE-TEST for testing data. So here we will load we will read the CSV file in WINE-TR and WINE-TEST. The next step will be creating a table for type and alcohol flag. We will look at different categories relate to each other. A contingency table helps us to see how often each combination of categories occur. So there is a table which shows how many wines. So we have a table which shows how many wines of each type have high or low alcohol content. We can then calculate probabilities from this. Then the next step will be the plotting of the data to visualize. To visualize, created a stack bar plot for alcohol flag and type. So the next step will be preparing data for Naïve Bayes. So now we will prepare the data. So since Naïve Bayes is a SQL in SQL and doesn't automatically handle categorical data, we need to convert alcohol flag and sugar flag into dummy variables, that is the zeros and ones. So first we will convert alcohol flag in test data to dummy variable. Then we will convert sugar flag in test data to dummy variable. Then we will combine alcohol and sugar dummies in test data. So after this, so in X, we have four columns representing high or low values for both alcohol flag and sugar flag. Now set up the target variable Y as a type of wine. So next step will be the to train the Naïve Bayes model. So now we will train the Naïve Bayes model using the multinomial NB. Using the multinomial NB, train the model with X and Y. Okay, then we will prepare the tested data. So for preparing the tested data, repeat the dummy variable conversion for alcohol flag and sugar flag in the test data, then combine them into X test. And after that, the next step will be making predictions. So we will make predictions using the trained model predict wine type for the test data, and then we'll evaluate the model. So create a contingency table to compare actual versus predicted wine types in the test data. So now we have
code. So this is the code. So in this we at first imported the libraries and we loaded the data set. Then we added the wine type as an additional column, and then we loaded another data set and then combined the data set. Then we did the pre-processing, then we did the train test split, then train naive base, and then predictions and the evaluation based on the accuracy classification report and confusion matrix. So now let's run the code. So here we got the output with accuracy 0.9666 something, and then the classification report we had the precision, recall and F1 score with red, with both wine types, precision, recall and F1 score with accuracy, macro average, weighted average, and also the confusion matrix. And just like that, we have predicted the class of a new wine sample based on the feature we provided. It's that simple with Naïve Bayes. We have seen how to apply Naïve Bayes to a wine dataset and how it can help classify wine samples based on their chemical properties, from loading the data to training the model, evaluating its performance, and even making predictions on new data. Everything comes together with a simple yet powerful algorithm. Thank you. I hope you understood the topic.